Hi there, this is Mr. Wolf. We're going to be doing benchmark 29 and 30 in this video lesson today. Benchmark 29 says that you can classify three-dimensional figures according to their properties. Benchmark 30 says you can use nets to analyze three-dimensional figures. And we'll get into those here right now. First things first, you must have paper and pencil there to take notes. You'll need to show at least one page of notes, preferably more, in order to demonstrate that you did watch this video. So when you come into class, have your notes ready to show to your teacher. Otherwise, you'll be watching this video again and taking notes. There is a lot of vocabulary to this benchmark, so it's important that you write everything down because we remember when we write. And it'll serve as a reference for future studying. Also, throughout the video, I'll probably show several slides that have lots of information on it. That'll be your cue to pause the video so you can copy everything down. Otherwise, I'm going to move right along. So let's get right into benchmark 29, 3D figures vocabulary. These are some of the vocabulary terms that you will need to know by the end of this lesson. Pause here and jot those down. Okay, first, let's talk about 3D figures and the pieces of them. Three-dimensional figures, or solids we'll sometimes call them, can be made up of flat or curved surfaces. And each flat surface, like this top of this box here, is called a face. So if we're looking at this rectangular shape down here, this three-dimensional shape, each one of the flat sides is called a face. The top, the bottom, the left, the right, the front, the back, all six faces. An edge is the segment that is the intersection of two faces. Another word for edge would simply be a line segment. Okay, so that's an edge, there's an edge, and so forth. A vertex is the point of intersection of three or more faces. So this point right here, that's a vertex. Vertex, vertex. A vertex is just the same as a point. So if you remember benchmark 1, we're really just going back to the very basics of geometry with planes, lines, and points. We're just calling them different things here. Okay, here's some of your 3D figures, and I'll enlarge the screen here so you can see them all. There we go. Pause here, write down the definitions, the terms that are highlighted, and I would draw these pictures as well. We're looking at a prism here. A prism is formed by two parallel congruent polygonal faces. Now that's a mouthful and kind of confusing, but if you look over at the picture, you'll see we're looking at two congruent triangles that are connected by three faces. All right, so that's a prism. And we're going to talk about different types of prisms in a moment. A cylinder is just two circles that are congruent, connected by a curved surface. A pyramid is formed by a polygonal base, and in this case it's triangular, but we'll see there's other kinds of pyramids as well. And a cone is simply a circle with a curved surface. Pause, jot these down. Okay, a cube is a prism with 6 square faces. You might think of like a Rubik's Cube or maybe like a pair of dice. Those are all cubes. Other prisms and pyramids are named for the shape of their bases. So this is very important to understand. A lot of the shapes we look at will involve prisms and pyramids. And to know what kind it is, you just need to look at the base. All right, so here we're looking at a triangular prism. We can tell that because the base is a triangle. Okay, two bases, top and bottom, and then we connect it with flat sides. This is a rectangular prism. Why? Because it has a rectangle on the top, a rectangle on the bottom. Pentagonal prism. There's a pentagon on the bottom and top. And the last one is hexagonal prism. There's a hexagon on the bottom and the top. And the same thing applies to pyramids as well. Triangular pyramid because the base is a triangle. Rectangular pyramid, guess what the base is? It's a rectangle or square. Pentagonal pyramid, hexagonal pyramid. Pause, jot these down, sketch some pictures. The more you write, the more you'll remember. All right, let's do a little quick, just a quick study here. What I'll do is I'll show you the shape, and in your head, or if you want to pause, guess what it is, and then I'll reveal the answer. This shape here is a triangular prism. Okay? What about this shape? Think about it for a moment. What is it? It's a rectangular prism. This one, 1, 2, 3, 4, 5 sides, so you should know this is a pentagonal prism. This is not a prism, this is a pyramid. To know what kind of pyramid, we look at the base. It's a triangle, so it's a triangular pyramid. Rectangular pyramid. Pentagonal pyramid. Okay. This says classify the figure and name the vertices, edges, and bases. So the figure, you might at first say it's a cube, but in order for it to be a cube, we'd have to know all the faces are congruent. So we could call it a cube, but technically I would say it's a rectangular prism. Okay. And then on the test, you might be asked to identify the vertices, the edges, and the bases. Okay, so let's just start with the bases. The bases are going to be often the bottom and the top, although it could be rotated, so it could be the sides. But for this, we'll call one base E, H, G, and F. So that's his bottom base. And then the top base would be A, B, C, D. Okay? Edges, there's several edges, but one of the edges we could say is right there, CG. And we label an edge just like a line segment, like that. Another edge is back here. We could say FG. All right? And there's several more. And the vertices are really simple. They're just A or B or C and so forth. It's just all the points where the edges meet. Okay, same thing here. I'll skip right ahead. Classify the figure, name the vertices, edges, and base. Now this is a cone, all right? The vertices, well, we can see the vertex is N. There's only one point. The base is base M, but there's no edges on a cone, so we just put none there. Okay, this shape we can see is a prism. It's got the flat sides, and the base shape is a triangle, so it's a triangular prism. Vertices are all the points, the edges are all the segments, and the bases are TUV up here and WXY. Okay, so that's all the vocabulary. That's all there is for benchmark 29. It's really not complicated. There's just a lot of vocabulary to learn. So writing things down, reviewing them a little bit every day is important. Otherwise, when you get to the test, your mind might go blank. Benchmark 30, I can draw nets of 3D figures, okay? So first question might be, what is a net? A net is a diagram of the surface of a 3D figure that can be folded to form that 3D figure. To identify a 3D figure from a net, look at the number of faces and the shape of each face. Okay, an easy way to think about this is, imagine taking apart a box and laying it flat. You know, what would it look like? So here's an image. Imagine this is a box that we unfolded and laid apart. Now, if we wanted to put this back together, what would it form? Well, the first thing that should tip you off is every one of these shapes is a square, and there's 6 of them. And you can imagine that if you folded this piece up, let's say we're looking down on this shape, okay? So all of this is flat on the ground. Let's leave this piece flat on the ground as our base. We fold this up, fold this up, fold this up, fold this up, and this would fold over the top and form the other base. We're looking at a cube. And that's what you have to be able to do on this benchmark, is look at a net and tell what shape it'll make, and go the other way. Look at a 3D shape and draw the net. Okay? Looking at this, you might think, oh my gosh, what is that? Well, this right here is the base. So if the base is a circle, okay, and we form this edge right around the circle, like that. Sorry, my writing's a little sloppy. What you'll find is that everything comes to a point, and this actually makes a cone. Okay? And we'll take a look at these in class with some real manipulatives. All right, next one here. Okay, so first thing I see is we got 1, 2, 3, 4 triangles. They look like they're close to being equilateral. Let's make this the base and pretend we fold this up and fold this up and fold this up. What do we get? We ended up with a pyramid, a triangular pyramid. And there's another one. This one's a little tricky. You got 2 circular faces and 1 rectangular face. So these are the bases. So imagine flipping these up to face each other and then roll them around this, and you end up with a cylinder. Something that looks like this. Okay? All right, polyhedron. This would be a good spot to pause and write down a little definition. A solid that is bounded by polygons, called faces, that enclose a single region of space. No curved surfaces. So polyhedron never have curved surfaces. Here's some examples. A cube is one. A tetrahedron, that's just a fancy name for a triangular pyramid. Dodecahedron, if you remember, dodeca means 12, so there'll be 12 surfaces on there. And there's some other ones, and icosahedron. These over here are not because they have curved surfaces. Okay? Please remember, what does this term mean in geometry? Regular. Well, in geometry, regular means all sides the same. Okay, so which ones of these figures are regular? Well, this doesn't have all sides the same. This doesn't, but this hexagon does. So this one is regular. And we can apply the same rule to polyhedra. So are all the sides same here? No. No. This one? Yes. They're all triangular sides, the same shape. And this one, almost all, but the base is a square, so it doesn't work. Okay. Here's some more polyhedra. We talked about this cube. We talked about the tetrahedron, or a triangular pyramid. There's an octahedron. We just saw one of those. Dodecahedron, and so forth. All right. And now let's look. Okay, so this is a triangular pyramid. All right, because I've got two triangles on each side. I'm sorry, a triangular prism. Got two triangles on each side connected by three flat surfaces. All right, now imagine unfolding it, and this might be a good time to pause the video and sketch what you think this would look like if you unfolded this figure, because I'm going to scroll down and show you what it looks like, and you can test yourself and see if you're close or not. So if we unfold these two red flaps down each side, and then we unfold the top, we end up with a shape that looks like this. Okay, so you can see here, there's those sides, the triangular sides that were folded up, and then these are the other two sides that we folded up with the triangle. This is the base that is on the floor, like here. All right, let's sum up here. We learned 3D shape names. Prisms and pyramids seem to be one of the most common. We just have to identify what type of prism and what type of pyramid. But there were a few extras that you wrote down in your notes. Also, we're learning how to draw nets from 3D figures and to draw solid figures from nets, going both ways. And we'll practice all of these skills in class, but it is of utmost importance that you come to class with good notes already on this stuff, with the vocabulary ready in your head, so that all we can do is just jump right into actually doing something with these shapes and manipulating these shapes. As always, if you have any questions, you can post a comment here on the YouTube page. You can text me, you can email me, whatever's clever. All right, for geometry, Mr. Woolf, signing out.